This is a long problem with a lot of numbers, but we can go through and analyze what the numbers are and then decide what equation to use. So just going through, let the units tell you. This one is a volume, milliliters. Here I have a mass. I also know what the substance is, so I could get a molar mass, and that could come in handy. Next I have a pressure and a temperature. And then I have a time. Then I have another temperature. And right there I see that this gas is going through a change, and I know one equation for gases going through changes. I need to label these 1 and 2. And then I have another pressure, and it's asking about the volume now, so that means after. Okay, like I said, I know of an equation that involves the before and after, and when you're doing something to a gas, okay. And so then we should say, well, do we have enough numbers to solve for V2? And I do. I have 2 pressures, 2 temperatures. I have my first volume. So I don't have to use this time of 10 minutes. That's just telling me, how long it took to go from situation 1 to situation 2. And the other thing is this mass, that could be useful in a lot of problems, but it doesn't come into play here. I have to make the assumption that gas is not leaving the balloon, that the same mass, we have the same mass before and after, because I don't have a mass after. So I'm not going to use that. I'm going to assume the balloon is sealed, and notice that it no longer matters whether there is helium or not. All that matters is that it acts like an ideal gas, because the combined gas law depends on it being an ideal gas. So I'm going to plug in, but I need to think about units. And I notice that my volume is in milliliters. Is that okay? Yeah, it's fine. Volume 2 will come out in milliliters. Remember, with this equation, you don't have to match to R. And so you can use any unit that you want for volume or pressure, as long as they're the same for the 1s and the 2s. Now, temperature must be in Kelvin. And that's true for all gas laws because you need an absolute temperature scale. So I'm going to start by converting my temperatures to Kelvin. Now I'm ready to plug into this equation. So I plugged in all my known numbers into their spot in that equation. And now I'm going to solve for V2. And the way I usually show this is to cross multiply before I go ahead and get my V2. And cross multiply means I'm going to take this top times this bottom and this top times that bottom. However you can get to the answer though. So now that I've done that, I'm going to divide both sides by all of this so I can get V2 by itself. Okay, and now I see these numbers cancel, these units cancel, and I'll have V2 by itself on this side. On this side, I see that millimeters of mercury cancel, K cancels, and so the only unit left is milliliters, and my answer will come out in milliliters. That's what my calculator says. But I need 3 sig figs, so let me just write this the other way. Put it in scientific notation to get 3 sig figs.